point number or a decimal point number, we are going to use a float data type for this average grade. And another data type that I would like to mention for also storing decimal numbers is called double, and the difference between double and float is that double is double size of float. So if you remember when we talked previously about taking memory space that variables take, so float is taking 4 bytes and double is taking double of that, so 8 bytes. So you can put much more data inside your double data type than inside float. And let's say, for example, that if you had a credit card and you had a lot of money, a lot of money, and you want to store that value inside a variable, you would use a double data type. So let's say double balance equals to this large number here, which I'm not going to even try to read. Okay. So these are the most common data types that we are going to use in this tutorial. I have said earlier that each data type takes a certain space in memory, but let's see exactly how much each of these take. For that, we are going to use something called size of operator, and let's see how we use it. So cout size of int is, and then we write this size of. So size of, and in parentheses we pass to it data type that we want to check how much memory it is using. So int. And if I run my program now, you see that it says that int takes 4 bytes of memory. And if you've ever actually studied binary algebra, you would know that 4 bytes of memory is actually 32 bits, since each byte has 8 bits. And as we said, our int can store both positive and negative numbers, and 0 also, remember that. So the first of these 32 bits is used to determine whether the number has plus sign or minus sign, so whether it's a positive or a negative number, and then remaining 31 bits are used for this value itself. So let's check what is min value for our int. Let's write that out. Let's write cout int min value is, and we have a reserved word for minimal amount for int in C++, and that is int underscore min. And if I run my program now, you see that it says this minus 2 billion, extremely hard to read this number, but you see that this is the minimal amount of int. So this number is actually 2 to the power of 31. Let's just quickly write these. So minus 1, minus 2, minus 3, and then minus this number here. So this number, as I said, is 2 to the power of 31. Why not 32? Because this 1 byte is used to represent this minus prefix. Now we should check a positive number range. So we also can write int max value is, and then there is another keyword in C++ for int max, which is int underscore max. And are you expecting to see this same interval but just with plus sign? So write in the comments, what are you expecting to see? And if I run my program, you see that that did not happen. And if some of you know why it did not happen, I would also like to hear what you think, why we have this number here and then this number here for our negative and for our positive range. So different ending number. And I'm going to explain why. Because this positive range here, we have to include 0 also. So in order to include one number here, let's just copy this and paste it. So our positive range is going to from 1 up to, let's say that it is this number, but since it is including 0 also, in order to include one number here, so 0, you have to take one number here. So this here is not 8 anymore, but is 7. So that is why we got, let's say, different number for our positive and negative range, because this here includes 0 also. One thing that I have to mention though is that if you want to use only positive integer numbers, there is a data type for that as well. And the data type that is used for that is called unsigned int. and its size is the same as of int, so 4 bytes or 32 bits. But since it is unsigned, that means that it does not use 1 bit for sign, because the sign is by default plus, but it uses all 32 bits to represent value, and those values go from 0 to, let's see exactly how big of a number, 4 billion and something. So cout size of unsigned int is, and let's see, size of unsigned int, this is the data type. And let's also write out what is the max value of unsigned int. So let's say cout uint max value is, and there is also a reserved word for that, and that is uint underscore max. So if I run my program now, you see that we got 4 billion and something number, so double the size of this. And this is actually 2 to the power of 32, but minus 1, because we are also including 0 in this range. So let's check these remaining data types. I'm going to write those out quickly and I will be back. So I have written here the rest of these data types, and as you can see, since our bool is only true or false value, 1 byte is enough for bool. Our char is using also 1 byte, float is using 4 bytes, double is using 8, and I'm also going to include a table with some more data types which we haven't mentioned here, so if you need to check those out, please pause the video. One thing that I promised to show you is data type overflow. Let's see what that is. So let's create a variable of type int and call it int max, and let's say that I want to store inside that variable maximum amount of int, so int underscore max. And I'm going to write that variable out now just to see how big of a value that really is. So cout int max, and if I run my program now, you see that I have gotten here this 2 billion, very large number actually. So that is the max amount of int. Now my question for you is, what is going to happen in this situation? So cout int max plus 1. What is going to be the result of our program now if I run it? So some of you may know this already, some of you may not, but I am very interested in reading your answers. So make sure to write your answers before watching my explanation on this. Write those in the comments down below. And if I run my program now, well, our number has not increased by 1, but it has went to the minimal amount of int. And why has that happened? Well, that is the data type overflow that I was talking about. And how this works actually is it works the same as your clock works. So it goes 9, 10, 11, 12, and then from 12, since that is the max value on your clock, it does not go to 13, but it goes back to min, so 1, 12, and then 1. And that is applicable here. It went from the max value to min value just by adding 1. And that is called data type overflow. I already can see that this video is pretty long, and I'm currently having problems uploading very long videos to YouTube. So I'm going to leave for the next video explanation of ASCII table, and we are also going to do some more examples and practice C++ some more. So make sure to subscribe to my channel and also click the bell icon so that you are first to be notified when I upload my next video, and also like it and share it with anyone who you think could benefit from this video. And I will see you in the next one. Hi guys, welcome to my channel. As I promised in my previous video, in this video I'm going to explain the concept of ASCII table, and then I'm going to give you an idea, an example of a program that is very beginner friendly, very simple, but also very fun, and that you can build only with knowledge from my 2 previous courses and this one. So if you haven't watched those, make sure to watch them. Link is going to be somewhere here and also in the description. And also make sure to like this video and to subscribe to my channel for more educational content. And let's begin now. So what is ASCII? Well, ASCII stands for American Standard Code for Information Interchange, and it was first created in order to standardize the way of representing characters in your computer. So in ASCII table, those characters are represented as numbers, numeric codes. And what this means is following. Let me give you an example. When I first learned to read and write, so when I was a little, I decided to, together with my friend, create our special symbol language where we would exchange each character with a special symbol that only two of us could understand, and then we would exchange letters using that symbol language, and no one else could understand those letters. And also, guys, write in the comments down below if you did that. I know you did, so don't make me feel like a weird one. Well, that is exactly what your computer does. It exchanges each character with a number so that it can understand it and it can communicate with other computers. So this means that your computer or ASCII table assigns to each character a unique number. And let's prove that now. So how we can do that is, in my Visual Studio, I'm going to say cout, and then in these parentheses, I'm going to say int, and then these single quotes, and I'm going to say letter A. And let's add end line. So this is one way of doing that, and then there is another way of doing just the same thing, and that is, let's say cout, and then int, and then inside these parentheses, we are going to say our single quotes and our letter A, and also add end line. So this here is called casting operator, and it is the operator that forces one data type to convert into another. And since we said that each character has its numeric pair inside ASCII table, well, we can ask our computer to give us that pair. So here I'm saying, please tell me what is my numeric pair of my letter A. So what number is my letter A? And if I run my program now, you see that I got 97. So our lowercase letter A is 97 in ASCII table. Let's check now a capital letter A. So I'm going to say cout, int off, and let's put our capital letter A and one more end line. So if I run my program now, you see that I'm going to get a different number, so 65. And this is so that your computer can distinguish between lowercase and uppercase letters. So ASCII uses seven bits to represent each character, and that means that it can represent 2 to the power of 7. That's how much characters it can represent, so 128 characters. And that is enough for all English characters, so all English lowercase and uppercase letters and numbers, and also some special symbols. But there is also a lot more languages, and also languages that have a lot more characters. So there is a lot more standards for representing those characters inside your computer. So this that we have just mentioned is called ASCII, and there is also extended ASCII. That is another standard that can represent more characters. Then there is also UTF-8, UTF-16, and a lot more different standards. So what we should remember for now that is related to ASCII is that ASCII represents each character with a number, so it holds its numeric match, its numeric pair in its table, and then that we can also get that numeric match using our casting operator. So this here is a casting operator. So now you may ask, if we can get a numeric value of our letter, so if we can get our int number of our letter, can we do vice versa? So can we get a character from our numeric value? And the answer is yes, we can convert a number into a letter also, and I'm going to demonstrate how we can do that in a moment. So you can say cout char, and let's say char of 65, and add end line. And if I run my program, you see that I'm going to get a letter A, so capital letter A. And now with this, when you learn this, you can get an idea on how you can build something more useful than just basic hello world application. So you can, for example, build a program that ciphers words and sentences in an ASCII, and then also a program that deciphers those messages back into English readable characters. So now we are going together to build a program that ciphers words into ASCII codes, and then I'm going to leave to you to build the program that deciphers those words back into English readable characters. So let's say that we want to cipher a 5-letter word. So what I'm going to do is, what I need to do is to create 5 char variables. So I'm going to create 5 char variables, then I'm going to let my user input his letters inside those 5 char variables, and then I'm going to write out encoded words. So I'm going to convert all of these letters in ASCII codes, and then I'm going to write that out to my user. So I'm going to, in a certain way, cipher his word. So I'm going to say here char C1, char C2, and then char C3. And I want to stop here for a moment. I want to explain one thing. When we first were talking about creating variables, we said that this is the way of creating variables. So you say the type of your variable, so char in this case, and then you say what name you are going to give to your variable. So in this case, this is our C1, C2, C3. So this way of creating variables here, it is correct, but it is a bit tedious for this current situation. There is another way of creating more than one variable, and I'm going to demonstrate that now. So what you can say also, what you can do is char C1, C2, C3, C4, and C5, and all separated with this comma sign. So you can create more than one variable in one line like this, but only if all of those variables are of the same type. And in this situation, they are. So all of these variables are of type char. So I've now created 5 variables of type char. And another thing that I want to mention is that in upcoming videos, we are going to learn how we can let our user decide how many characters, how many values he wants to enter during the execution of our program. So now we have hard-coded these 5 values, but we are going to learn more in the following courses. And also another thing is that also in C++, there are a lot of solutions that you can use already made so that you can enter whole words or sentences, so you don't have to enter your word letter by letter, so you don't have to create variable for each letter that you want to enter. But what I'm trying to explain here and what we want to understand here is how it really works in the background, so how it works inside. You have to understand that, and I believe that that will give you a great advantage over those programmers that just know how to use something rather than how to make that something by themselves and then use it. So I have here created 5 variables, and each one to hold a character that we will enter, and let's enter them now. So what I'm going to say is cout, enter 5 letters, and then I'm going to say cin, and I'm going to put all my variables here. So C1, C2, C3, C4, and C5. So if you can see here, I have entered all of my 5 variables in a single line. So you can do this. You can bind these operators like this so that you can enter more than one variable in a single line. The same way that you can bind your cout operator so that you can write out more than just one string. So now what we are left to do is we have to write out our ASCII message. So what I'm going to say is cout ASCII message, and then I'm going to put int C1. Let me write that out really quickly. So I have written this message here, and what I have said is console output ASCII message, and then I have combined these cout operators so that I can write more than one variable in a single line, so in a single command actually. So I have said give me my int code of my C1, so give me my ASCII code of my C1 variable, and then put a blank space, and then give me my ASCII code of my C2 and also C3, 4, and 5. And I have also used these blank spaces because I don't want to write just a single number in a single line, because I want to know where my first character ends and where my second character begins. That's why I'm going to separate those codes with an empty space. And also there's another thing that I want to mention, and it is that when you want to convert your variable, so the value that you are holding in your variable, and when you use your casting operator on that, you don't put your variable in a single quotation marks, you just put the name of your variable, like this example here. So if I run my program now, you see that I get my message, so enter 5 letters, and I'm going to enter hello, and you see now that I have this output ASCII message is 104, 101, so 108 and 108, so that is our letter L. You see that it has the same code, and now I have gotten this ASCII message, which is our ciphered word. And also there is one thing that I want you to keep in mind, and that is that this program here will not take into consideration your enter or your space key as a letter. So if you put your enter or your space key however much times you want, it will not treat it as a character. There are some other functions that you can use in your C++ if you want to capture your enter, for example, or your space key, such as cin.get. If you really want, you can Google that out. But at this point, we are keeping this very beginner friendly, so this will not capture your enter and your space. So let's just prove that. I'm running my program once more, and I'm going to put enters and spaces, and you see nothing is happening. And then if I enter hello once more, you see that I'm going to get the same numbers, so the same message as before. So we have built here a program that ciphers our words into ASCII, and we have built this program after just studying a little bit of coding. So imagine what you can do if you learned more. So stay tuned, make sure to subscribe to my channel, and also like this video if you want to support me in filming these videos. And also, I'm going to leave to you to write a program that is going to decipher these messages from ASCII back into readable English words. So you also can put your suggestions of a code in the comments down below. And also what you can do, you can upgrade this program here that we have written so that you can put in more words, more sentences if you want, and then you can put those encoded messages in the comments, and everyone who wants to read those messages is going to have to build a program that is going to decipher those messages into readable English. So subscribe to my channel, like this video, and I'll see you in the next one. Hi guys, welcome to my channel. In today's video, I wanted to show you something that you are going to be using very often if you start on a programming path, and that is if-else statement. So what is if-else statement? Well, if statement is something that is used when you want to execute part of your code, so block of your code, conditionally, which means not always, but only in a certain situation. And then if you add else block to that else block is going to be executed otherwise. So in the situation where your if block is not executed, your else is going to be executed. So let me explain that to you in a simple example. Here I have opened my Visual Studio, and let's quickly paste an exercise that we are going to do in this tutorial. And that is this task here. So let's say that our user has to enter a number, a whole number, integer number, and then after that our program has to check whether that number is even or odd and has to write out that to our user. So how we are going to solve this problem here? Well, I'm going to explain this to you using diagrams, because I believe that that is the best way for you to understand this if you haven't used this if-else statement before. And then what we are going to do after we understand those diagrams, well, we are literally going to just translate that diagram into our C++ code. So let me open my tool. Here I have opened a tool that I'm going to be using for drawing diagrams. It's called Blank Diagram. You can use whatever tool you want. You can use even a paint or a pen and paper if you want. That will work as well. So here I'm going to draw the flow chart of our program, so how our program is going to be executed. And let me add first here this shape, and we are going to say that this is going to be the start of our program. So I'm going to write out start, and this indicates our main function, let's say the first line of our main function. So here our program starts. And then, as we said in our task, in our exercise, our user has to enter an integer number. And the shape that we are going to be using for that is this shape here. So let me put this shape here. And I'm going to write a text inside, and I'm going to say int number. So this shape here indicates that our user is going to enter some data in our program. And why I'm using this shape, because it looks like this. It looks like a funnel. So you can clearly visualize that something has to enter inside that shape. So something has to be inputted in your program. So I'm going to use this shape for that. And then I'm going to say that our user has to enter an integer number, which I'm going to call number. So that variable I'm going to call number. And let's quickly add this arrow so that we know that this is the flow of our program. So after it has started, our user enters a number. And then after that, what we have to do is our program has to decide whether that number that user has entered is even number or odd number. So how we are going to do that? Well, the shape that I'm going to be using for that decision, let me find it. Well, it is this shape here, so this diamond shape. And as you can see, it says decision on it. So that's the shape that we are going to be using. And inside this shape here, I'm going to write a condition. So as you can see, our program flows this way. And after it comes here, as you can see, it has one entry point, and then it can have multiple flows that it can go to, depending on this condition that we are going to put inside here. But how we are going to decide whether that number that our user has entered is even or odd? Let me very quickly open my Visual Studio once more. It is here. And let me show you something. I want to introduce you to an operator that is called modulo, and that is used to show what is the remainder of dividing two whole numbers. So I'm going to write out cout, and then what I'm going to write out is, let's say, 2 modulo 2. So this operator here gives you the remainder of dividing these two numbers. And in this situation, we are expecting to see a 0, because 2 divided by 2 is 1. And then what remains after that operation is 0. And that what remains should be shown when we use this operator here. So if I run my program, you can see that we have gotten the expected result. So we have gotten 0 here. But let me show you what happens if I enter, for example, 5. Well, what we are going to get is 1, because 5 divided by 2 is going to be 2, and then that 1 that remains we can get using this operator, and you see that it gives us the expected result. So 5 modulo 2 is equal to 1. So this operator here is what we are going to be using to determine whether our user has entered even number or odd number, because when we get the result of modulating two numbers, when our result is 1, that means that our user has entered odd number. And if we get 0 as a result of this operation, that means that our user has entered even number. So I'm going to switch again to my diagram, and then inside this decision here, we are going to write this condition here. So I'm going to say number modulo 2 is equal to 0. So what this means, it means that after our program has started and our user has entered the number that he wants, an integer number, we are coming to a decision point where we have to decide whether this number that he has entered, after you modulate it with 0, whether it's a 0 remainder or some other remainder. So in this situation, when this is 0, we are going to execute a certain part of code. And then let me add very quickly, oh, I'm impressed. It already has this yes inside it. And then we also have this no on this other line. So in this situation where this results as an operation that is true, we are going to execute this part code of here. So I'm going to add another shape, which I cannot see, but let me use this shape once more, and I'm only going to rotate this shape like this. And I'm going to delete this text, and what we are going to be using this shape here for is to indicate that we are going to output something from our program. So it looks like this, which is clearly a visual of something is going to be outputted from it. So it is just reverse of this shape here, this funnel shape. And then inside this shape, let me write a text which is going to be, let's say that in the case that this here results as a yes, as a true operation, so our number, when it's modulated by 2, it gives a 0 remainder, we are going to say that that number is even number. So we are going to write that out to our user. And then in the situation where this here results as a no, so as an operation that is false, let me write out that here, and I'm going to say to our user, so I'm going to write out to my user that he has entered odd number. And let's just join this here like this. Okay, so our user enters a number, then we decide if that number modulated by 2 gives us 0, and if yes, we are going to write out to our user that that is an even number. If no, we are going to write out to our user that that number is odd number. And this is here really our program. What I'm going to add is, let's say that after this, our program is going to stop. So I'm going to say here that this is the end of my program, like this. And let's add one more stop of this flow here. So in both of these situations, after we have outputted to our user the result of this program, our program is going to stop. And this here really, like these two stop points, look a bit ugly to me. So what I'm going to do instead of this, I'm going to delete this. You could have as well left it like this, like it was before. But what I'm going to add one more of these diamond shapes, only this time it's going to be smaller. And I'm going to say that in this situation, it is going to be used only to say that this decision here, this decision flow is going to be joined in this point here. So like this, I'm going to say whatever has happened, whether this block of code or this block of code, it has come to an end here. And then after that, from here, I'm going to say, now my program is going to stop, like this. And this, let me remove this yes. And this is going to be the flow chart of our program. So our program starts, then our user enters integer number. Then we decide whether that number modulated by 2 is going to give us 0. If yes, we execute this. Else, we execute this. So if this is no. And then we come to this, which joins our two paths, and then we can say that our program has ended. And now let's translate this to our code. Here I have opened both my Visual Studio, and also I have exported this diagram so that we can translate it literally. We can look at this diagram and then translate that into code. So now I'm going to delete all of this that we have written inside our Visual Studio, and I'm going to look at this picture and just translate it into C++ commands. So this first shape here says that user is going to enter integer number inside our program, and we are going to call that variable a number. So I'm going to say int number, and then this here, this funnel shape, really translates into cin command. So user enters something inside our program, and that is cin command, and I'm going to say that user is going to enter a number. Before this, I would like to add one more information to our user so that he knows what he should enter. You could have as well put that to our diagram, but I didn't want it to make that diagram crowded, so I didn't. But what we are going to add here is cout, and then say, please enter whole number, like this. So we write out a message to our user, and after that our user, as you can see here, enters integer number. We had also to declare this int number variable, because you can enter the value only for variables that you have previously declared. And then after that our program comes to this decision point. And how we can represent this decision inside our code is using if statement. So we are going to write here if, and then I'm going to put this condition here inside these parentheses. So I'm going to say if number modulo 2 equals 0. This here is operator of equal, so whether this side is equal to this side, since only one of these, so like this operator here is used to assign value to a variable, so that was already taken. So this here, two of these signs are used to check equality of these two sides, so whether this is equal to this. And then what I'm going to say, as you can see from my diagram here, we check this condition here. And if this condition is true, if this condition is yes, we are going to execute a certain block of code. And that is this code here. And how you indicate a block of code in your C++ is using these braces here, like this. So this is your block of code that is going to be executed in this yes situation. And then in case that this no here happens, so in case that this results as false, you are going to execute another block of code, and we represent that block of code using else statement. So we are going to say if this here is true, execute one block of code, else if this here is false, execute another block of code. So here, what our if makes us do? Well, it says that we only have to write out to our user that he has entered even number, because this shape here, as you can see, it looks like this, and it represents that something should be outputted from your program. So we are going to use for that our cout command. So cout, you have entered even number. So like this. And let's add end line. So in case that this here results as true, we are going to output to our user that he has entered even number. Else, if this here results as false, we are going to output to our user, let me copy this, like this, and we are going to change that only to odd. So in case that this here results as false, we are going to output you have entered odd number. So either this here is going to be executed or this here, depending on this condition. And you can see that from diagram clearly. So when your program comes to this decision point, it checks this condition, and if the answer is true or yes, it is going to execute this. Else, if the answer is no, it is going to execute this. And then after that, it really just joins these two flows, and then that is the stop point of your program. So we can write here cout, thanks, bye. Okay, let's say that is the last line of our program. I haven't put this on my diagram. Okay, so I'm going to run my program now, and as you can see, it says please enter a whole number, so this line here. And if I enter, for example, 8, it is going to come to this line here, and it is going to modulate our 8 with 2, and if the result is 0, which it is going to execute this line here and write out you have entered even number. Oh, thanks. We are missing an S here. And then it writes out thanks, bye. And let me add an S here. Okay, and if I run my program again, as you can see, it asks me again to enter a number, and this time I'm going to enter 5, which we know that is an odd number. It says you have entered an odd number because it has come to this decision point here, it has tried to modulate 5 with 2, and the result of that was not 0. So it has not executed this, but it has executed this else statement, and it has written, you have entered odd number, as you can see here. And then this, thanks, bye. Okay. So I hope that you have understood this, and if you like me to use these diagrams to explain some more code that we are going to be using, you can write that in the comments down below, and I'm going to try to use more of these diagrams because I know that some people understand it better when there is a visual representation of your code. I was one of those people when I first started learning programming, so if you find it easier to understand when I use these diagrams, I'm going to be using that. So thanks for watching this video. Make sure to like it if you find it any helpful, and also to subscribe to my channel, and I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. In this video I wanted to talk about if-else statements, but a bit more complex if-else statements so that you can get an idea on how they are used in real life. So if you're not familiar with them at all, like you have never heard of if-else statement, then you should probably first watch my first video of this subject, and I'm going to link it somewhere here, and then you can come back to this video. But if you're already familiar with the very basics of if-else statements, then this video is right for you so that you can upgrade your knowledge. So keep watching. So the problem that we are going to solve in this video is the one that students usually get on their exams a lot. And with the knowledge that you get from this video, you are going to be able to recognize and solve other problems of this type. And also, if you don't want to work with C++, this logic that I'm going to teach you today is going to be applicable in other programming languages as well. So here's the text of my problem, and it says that our user should enter the side lengths of a triangle, so A, B, and C. And after that, our program should write out whether that triangle is equilateral, isosceles, or scalene triangle. And as you already may know, equilateral triangle is the one that has all 3 sides of the same length. Isosceles triangle has 2 sides of the same length, and then scalene triangle is the one that has all 3 sides of a different length. So the way that we are going to solve this problem is we are going to really visualize the solution for this problem so that you can really understand it, and that is going to be using diagrams. The tool that I'm going to be using for drawing diagrams is called Blank Diagram. You can use whatever tool you prefer, even pen and paper if you want. And the first shape that I'm going to put to this diagram is going to be this circle shape here. Let's say that it is going to indicate the start position of our program. So here's where our program starts. And after our program has started, what we want is we want our user to enter side lengths of our triangle. And the shape that we are going to be using for that is this funnel shape here, so that you can clearly visualize, because of this funnel shape, that something should enter inside it, something should be inputted in your program. And what should be inputted is side lengths, so A, B, and C. And the type that I'm going to be using for these 3 variables is float. Why float? Well, because the lengths of sides of a triangle can be decimal point number or floating point number. So float. And then let's put this arrow here so that you can visualize the flow of our program. It goes like this. And then after our user has inputted the side lengths, what we should do is we should determine whether he has entered equilateral triangle, isosceles triangle, or scalene triangle. And what I'm going to do next is I'm going to use this diamond shape here, which indicates decision in your program. And what I'm going to put inside this shape here is condition. The first thing that we want to check is whether our user has entered equilateral triangle. So whether these 3 sides are all of the same length, whether these 3 variables hold the same value. And let me make this a bit bigger. And inside here I'm going to say, please check if my A is equal to my B, and also if my B is equal to my C, like this. So let me join these two. And I want to explain two things when it comes to this. First one is this operator here, this AND operator, these two ampersands. This is logical AND operator, and it is used as I'm going to just explain. So this expression here is going to result as true expression only in a situation where this here is true, and also at the same time this here is true. So in that case, this whole expression is going to result as a true operation. That is the logic behind this AND operator. And the second thing that I want to explain is following. So I have said here, please check if my A side length is equal to my B length, and also if my B side length is equal to my C side length. What you can also put here is, you can also say A, because we have determined here that these two are of the same length. So it really doesn't matter if you put here A or B, whichever you prefer. So in this situation where this results as a true operation, we are going this way. And what I'm going to do when this results as a true operation, as a yes operation, I am going to use this shape here. Let me just rotate it. I really don't see a shape that is this one, so that's why I'm using this reverse funnel shape, and I'm rotating it so that you can clearly visualize something that is being outputted from your program. Let me delete this text here and make it a bit wider, and I'm going to put text inside it. And what I want to write out in this situation here, where this results as a true operation, where this condition is fulfilled, is that our user has entered equilateral triangle because all three sides are of the same length. So let me write that out. So in case that this condition here is true, we are going to write out to our user that he has entered equilateral triangle. And then let's check the situation where this here results as a no operation. So in that case, we have to determine whether our user has entered scalene triangle or a isosceles triangle. And for that, I'm going to be using another of these diamond shapes, so another decision that we have to make. And let's put it here. And oh no. And the next thing that we want to check is following. So I want to check once I have determined that my user has not entered all three sides of the same length, I want to determine whether he has entered all three sides of a different length. So I'm going to put inside this shape here another condition, and I'm going to say following. So please check if my A is not equal to my B, and also at the same time if my A is not equal to my C, and also at the same time if my B is not equal to my C, like this. So this is the next condition that we want to check, and this operator here is called not equal to operator, and it is really reversed from this equal operator. It has reversed logic. So in this condition here, what we want to check is whether my A side length is not equal to my B side length, and also at the same time whether my A side length is not equal to my C side length, and also whether my B is not equal to my C. And if this here results as a true operation, that means that all of these three side lengths are not equal. They all have the different lengths. So in that situation, we are going to go this way. And we are going to write out, let me copy this shape. And here I'm going to say, please write out to my user that he has entered a triangle that has all three different side lengths. And that is going to be our scalene triangle, like this. Okay, so in the situation where this here results as a true operation, it means that all of these three are of a different length, and we write out to our user that he has entered scalene triangle. And then the situation where this here results as a no, because we have previously determined that these three are definitely not of the same length, and then we have in this condition here determined that these three are also not of a different length. What is left is that the two of these three sides are going to be of the same length. And that is going to be the situation where we write out to our user, well, I can copy this, and we write to our user that he has entered isosceles triangle. So let me write that out. Okay, so these three are three potential endpoints of our program. So three potential solutions to our problem. And after we write out to our user this or this or this, I'm going to really put this one diamond shape just to indicate that our decision has now come to an end. We have solved this problem and we are going to join these paths in this shape here. So I'm going to put this and this like this. So now, after we have decided whether it's an equilateral triangle or scalene or isosceles, I can now say you can resume the execution of my program normally. So whatever I put after this shape here is going to be executed in either this case or this case or this case. And what is going to be happening after this shape here is just stop. So our program is going to stop, but you can put a lot of code here if you need to. So I'm going to say stop. And let me delete this, really, I don't need it. Okay, let's explain one more time this diagram. So after our program starts, our user should enter A, B, and C, which represent side lengths of a triangle. And I have used this float shape since those side lengths can be decimal point numbers. And after our user has entered that, we come to this decision point here. And what we want to decide here is, first thing, we want to check whether all of these three variables are of the same value. So whether he has entered three same lengths for a triangle sides. And in case that this here results as a true operation, we are going this way. And we write out to our user that he has entered equilateral triangle. And after that, we go this way and our program stops. In the situation where this here results as a no operation, we want to check something else. So we are going this way and we come to another decision point. And here we want to decide whether our user has entered a triangle that has all three different side lengths. So after we have checked that they are not equal, we want to check whether all of three variables are of a different value. And in case that this condition here results as a yes operation, that means that he has entered scalene triangle. But in case that this here results as a no operation, we can now clearly say that he has entered isosceles triangle, because we have checked here that these three sides are not the same, and we have checked here that these three sides are not different. So all of them are not different, and that means that two of them have to be equal. And in that situation, we go this way and we write out to our user that he has entered isosceles triangle. And now we can go this way, and you can see that in this situation as well, our program stops. Here I have opened my flowchart and my Visual Studio so that we can just translate this diagram into our C++ code. So the first thing here is our user enters our A, B, and C side lengths. So let's declare three variables of type float, and let's call them A, B, and C. And now I'm just going to write out a message to my user so that he knows what he should enter. So let's say cout, and please enter A, and then B, and then C, like this. And then let's use our cin command so that he enters his values. Okay, let's say first thing that our user enters is going to be stored inside my A variable. After that, what he enters, please store that inside my B variable, and then the third value that he enters is going to be stored inside my C variable. So now that we have entered our side lengths of a triangle, we come here, so to a decision point, and we said that we represent this with if-else statement. So I'm going to write here if, and then inside these parentheses I'm going to say this condition here. So please check, like this, please check if my A is equal to my B, and then also check is my B equal to my C, like this. And if this expression here results as true expression, I'm going to execute one block of code, and that block of code is going to be this one here. But if this expression here results as a false expression, okay, I am going to execute another block of code, and that block of code we represent with our else statement, like this. Okay, and then let's write this yes situation. So let's write here Cout equilateral triangle. So like this. Oops, you should put that not in a quotation marks. Okay, so in this situation where these three side lengths are equal, we write out to our user that he has entered equilateral triangle. But in the situation where this here results as false, we have this else block to execute. And let's find out what is inside our else block. So it is this code here. And that is another if-else statement. So this if-else statement is really nested inside this one here. So it is nested inside this else block. So here in these brackets here, we are going to put another if-else statement. So let me write out if, and then inside these parentheses, we put our condition from this decision here. So from this diamond shape here. And I'm going to write out, please check if my A is not equal to my B, and then is my A not equal to my C also, and then is my B not equal to my C. So in this condition here, we check whether all of these three variables have different values here. And if they do, if this condition results as a true expression, I'm going to write out, let me just copy this, and then we are going to adjust it. I'm going to write out that my user has entered a scalene triangle, as you can see here. So when this goes in a yes way, we write out that message. So if this results as a true, we write out that our user has entered scalene triangle, but if this here results as a false, then we are going to write out that our user has entered isosceles triangle. And let me copy this, like this. Okay, so we have nested this if-else statement inside this else block. So this if-else statement is going to execute only in a situation where this here results as a false expression. So this code here, if you find it a bit unreadable, I want to show you one trick, so one rule that you can really follow, and that is if you have only one command under this if or else statement, you don't need to use these brackets. So you don't need to say that you are going to execute a block of code, since you are not. You are going to execute only one command. So you can really delete this here, like this. And then also here, since we have only one command, both here and here, we can delete these brackets here, like this. Okay, so now this code is a bit easier to read. Okay, now, as you can see from this diagram here, it is literally translation of this here and vice versa. So this code here is a translation of this diagram here. And what it means is when our user enters three values for our sides of a triangle, first we are going to check whether all of these three sides are equal. If they are, our program is actually going to say that our user has entered equilateral triangle. But if this here results as false, then we are going to our else block, and then inside that else block we are going to nest another if else. So we are going to check another condition. We are going to execute this if else here, and this if else here is going to check following. So it is going to say, please check if all of these three variables are different values. So if all three sides of a triangle have different lengths. And if they do, we can say that that is a scalene triangle. But if they don't, then since we have already checked that all of them are not equal, and also we have checked here that all of them are not different, we can say now that definitely two of these variables are equal, and that means that our user has entered isosceles triangle. And that is the program that we had here. Okay, so I hope you liked this video, and if you did, this is a strong call to subscribe to my channel and to share it with anyone else who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to another video of C++ for beginners. In this video, I wanted to talk about operators in C++, and we are going to cover the ones that are used most of the time, but I'm also going to make a separate video for certain operators that have specific use in C++. So in this video, we will talk about the ones that are used most of the time and that you really need to know and understand. And also make sure to watch the entire video because I do have some important tips to give you when it comes to this that you really need to understand and that you will find handy for your future progress in learning of programming. The first thing that I wanted to explain is what are operators. You can understand operators as special type of functions that are used to perform certain calculations on arguments or operands, and then based on those arguments and on that calculation, they give you a new value. So the first type of operators that I want to talk about are arithmetic operators. And you are probably familiar with most of these. So there is operator of adding and subtracting, multiplying, dividing, and also one more operator that you may not be familiar with, which is the modulo operator. So all of these are arithmetic operators. And let me give you an example of how these are used. So I'm going to say cout, and then let's write out the result of 5 plus 2. Now let's add one end line. Okay, so this here is the operator of adding, and then these two are operands or arguments, and this here is going to perform certain calculation and then write that out to my console. So if I run my program, we get the expected result, which is 7. So these really behave as you would expect them to behave in maths. But there are certain rules that are specific to programming and that I want to mention. So this operator here, operator of dividing. Let me give you a simple example. If I say cout and then 5 divided by 2 and I add end line, what do you expect to see in this line here? Write that in the comments down below. Now I'm going to run my program, and you see that the result that I've gotten from this line here is 2. But why has that happened? We know that 5 divided by 2 is 2.5. Well, there is a certain rule in programming that says that the result of dividing two whole numbers like this, so 5 is whole number and then 2 is also whole number, is also going to be represented as whole number. So even though the result of dividing these two is 2.5, that 0.5 cannot really be put inside integer variable, so it cannot be put inside integer container. So just 2 can be put here. And that 0.2 is really lost. If you want to show the real result of dividing these two, what you have to do is you have to make one of these two or both of them of a different type. And that type is going to be decimal point number, so float or double. So if you put here 2.0 or you put here 5.0, then in this case, you are going to get the result represented as decimal point number. So you can use it like this, or you can make just one of these of a floating point type. So you can say also like this. And then if I run my program now, you see that now I have got the expected result, so 2.5. That is one rule that you really need to know when it comes to this division operator. And another tip that I want to show you is this operator of modulo. So how do we use this modulo operator? This example here that I've just shown you, let me return this to this situation where I've been dividing two whole numbers, and